Okay, I wanted to do some examples where we are talking about working with some complex numbers. And so these are just a brief kind of mini lesson on how to simplify some of these different types of problems. So the first things first, when you're dealing with a complex term, is that means we're dealing with this imaginary term I. So there's a few things in this particular problem that I want to do. First, I need to know what I'm doing, and here I'm going to simplify. So simplify just essentially means I need to combine my terms together and make it as small as I can. I am subtracting, so this is going to be one of the most important things to keep in mind, because that negative sign is going to need to be distributed through the back part of your parentheses. However, before we get there, we have to deal with my radical. So in this case, we need to evaluate or simplify with your complex. Okay, so what does that mean? What that means is this negative sign here has to be pulled out of my radical, and this represents your I term. So what happens is we end up getting the square root of 25, and then we have I along for the ride. And then when we evaluate 25, or the square root of 25, remember that breaks down into 5 and 5. Since my index is a 2, you would pull out your group of 2, and therefore this would end up being 5I. So the first thing you always need to make sure you do is you need to make sure any and all complex radicals have been rewritten in terms of I. Now that we've done that, we need to go ahead and rewrite our problem, and so we have here 3 minus I, and we're going to subtract away 4 plus 5I. Now that that's been done, we need to take this negative and we have to distribute it through the back parentheses here. So in this case, we're going to have 3 minus I minus 4 minus 5I. Now we need to go ahead and combine. My I terms will combine with each other, and my constants will combine with each other. And what we need to remember is we need to remember that your complex number or complex form must be A plus or minus BI, always. So in this case, what that means is it means you're going to write your constants first. So it's written as your constants plus or minus your imaginary. Okay, now another word for your constants is real. Okay, so in this case, if we look, I have 3 minus 4, so I would group those together. So I've got 3 minus 4. And then I have negative I, so negative I, and minus 5I. When I reduce those, we're going to end up with 3 minus 4, which is negative 1. And then negative 1 minus 5 is going to give you a minus 6I. I am in the form A plus or minus BI, and so this is my simplified result. All right, let's take a look at another one here. In this case, we have a division problem, and so when we are dividing with our imaginaries, the biggest thing that we have to remember here is you have to remember that you cannot have I in the denominator. So this means that I have to rewrite this equation, but I have to use a very specific fact. I need to use your complex conjugate. Okay, so this is what we have to do. So in this case, my complex conjugate is just that. It is going to be the opposite sign of what I have. So here, my complex conjugate is going to be 3 plus I. So what I have to do is I have to take what I have and I have to multiply both the top and the bottom by that complex conjugate. So I'm going to have my I divided by 3 minus I, and I am going to multiply top and bottom by 3 plus I over 3 plus I. Now my goal is that when I multiply these bottom terms together, the I cancels out. So let's see what happens. So I'm going to have my big old division line, and I'm going to FOIL the bottom. So if you remember, what we're doing here is we are going to FOIL these together. So first, outer, inner, last. So 3 times 3 is going to be my first. I have to add it to my outer, so that'll be 3 times I. I need to add it to my inners, negative I times 3. And add it to my last, negative I times I. Now, once I FOIL this together, the part that I'm looking for is that this middle term cancels. Okay? So, if we take a look at that, 3 times 3 is going to give me a 9. And this is going to be plus 3I minus 3I minus I squared. So if you look, these two middle terms will completely go away. Now, some may be thinking, hold up, I still have an I down here, so it didn't work. Well, that's not entirely true. We need to remember that we have a rule, and that rule says that I squared is equal to negative 1. Which means this I squared right here we have to replace because this equals negative 1. Because of that, i's go away, so what we need to do is we need to do this numerator piece. My numerator says I have to distribute, and I'm going to distribute my I through that parentheses. So this is going to become I times 3, and then we're going to add this to I times I. So when we reduce that down, this becomes 3I plus I squared. Now again, we have this rule. So this is an I squared that also has to be replaced. So let's go ahead and do that. I squared is negative 1. So my new numerator is going to be negative 1 plus 3I. In the denominator, this becomes 9 minus a negative 1. Now, one of the things that we remember is that minus a negative is the same as plus. So when we reduce, what we end up with here is we end up getting negative 1 plus a 3I. 9 plus 1 is 10. Now, if you look at this, technically this is not our complex form. So we need to break our fractions apart, which means we are going to have negative 1 over 10 plus 3 over 10I. Okay. Let's look at another one here. In this one, the first thing that we have to do is we have to take care of the radical. So here we need to simplify. And we have to simplify by remembering that this pulls out, the negative pulls out as the I. So what we are left with here is the square root of 16 with an I off the back. 16 is going to break down into 4 times 4. So this is going to equal 4I. Now we need to do the same thing here with this last one. We need to simplify. Again, this means we need to start by taking my negative and pulling it out of the radical as my I. This is going to give me the square root of 4 with an I off the end. And then we know that 4 is going to break down into 2 and 2. Therefore, we end up getting 2I. So once we reduce those, we need to rewrite our problem. So this is going to be 3 minus 4I times 5 plus 2I. Now that we're in our complex terms, we have to FOIL. So when we're looking at this, what we have to remember here is in order to combine says we have to FOIL. If you don't remember what FOIL is, it's first, outer, inner, last. So what we're doing is we're multiplying our first terms together, we're multiplying our outer terms together, we're multiplying the inner terms together, and we're multiplying the last term. And if you look really close enough, you can kind of see a smiley face here in your binomials. So let's go ahead and actually do that multiplication. So first terms are going to be 3 times 5. We need to add it to that outermost term. So in this case, it's going to be 3 times 2I. Add it to your inner terms, which is a negative 4I and 5, and add it to your last terms, negative 4I times 2I. Once you've done your multiplication, all you have to do now is simplify each step. So when we look at it, this part, 3 and 5, becomes 15. If we look at this next part here, 3 times 2 is 6, so this becomes positive 6I. If we look at this next part here, we have a negative 4I times 5, makes it minus 20I. And then in this last part here, I have negative 4I times 2I is a negative 8I squared. So we need to put some things together here. First, I have these two I terms. These can be combined. Second, I have this I square. So remember, I squared equals negative 1. So we have to rewrite it. So in this case, I have 6 minus 20. So you're going to go ahead and do the math. 6 minus 20 gives you negative 14. And then you're going to bring the I along for the ride. So this is going to be 15 minus 14I. And then this becomes minus 8 times negative 1. Well, negative 8 times negative 1 is positive 8, so this is going to be 15 minus the 14I plus 8. We need to combine our terms that are together, so I have this 15 and I have this 8 here. So we're going to combine those together, and we're going to get 23. And so here we're going to end up with 23 minus 14I. Now if you look at it, this is in my complex form, therefore this is my result. Alright, we've got a couple more here that we're going to take a look at. So here's the first one. What I want you to notice about this is even though I've only written one binomial, I've got this little power. This power here says that you actually have two of them. So to have two of these essentially means my problem is really 2 plus 3i times 2 plus 3i. Again, we are going to combine these together by FOIL. First, outer, inner, last. So my first terms are going to be 2 times 2. Add it to my outer terms. In this case, it's going to be 2 times a 3i. Add it to my inner terms, and we're going to have 3i times 2. Add it to my last terms, and we have 3i times a 3i. We have to go in and we have to reduce and combine each individual piece. So this first part here is going to become 4. This next part here is going to become 6i. This next part is again 6i. And this last part is going to be 9i squared. Now notice all of these are going to be positive, so I'm going to go ahead and input my addition signs here. And now we need to combine some more. First and foremost, my middle terms. These you will combine through addition. The last thing that we have, excuse me, is this I squared term. So again, remember, we know that I squared equals negative 1. So we have to input that into the problem. So we're going to go ahead and reduce down some more. So this becomes 4 plus, well, 6 plus 6 is 12, so this is 12i. And then I'm going to have plus 9 times negative 1. Reduce even further, this becomes 4 plus 12i minus 9. I need to combine my terms, so I've got this 4 and this negative 9 that need to combine. So here I end up with negative 5 plus 12i, and this is my result. Okay, last but not least, we have one more division problem. So again, we have to multiply by the complex conjugate. In this case, my complex conjugate is going to be negative 2 minus 3i. So when we're working these, what you need to realize or remember with your complex conjugate is the only thing that changes is your sign of the complex term. Everything else stays the same. So again, we are going to take our problem, so 7 minus I over negative 2 plus 3i, and we are going to multiply it by that complex conjugate, which is the negative 2 minus 3i over the negative 2 minus 3i. So in this case, we again are going to FOIL. We're going to FOIL top and bottom. So to start with, I would draw a good old dividing line, and I would work with the bottom first. Okay, so I would FOIL the bottom first. Now the reason I would do that is because the whole point of doing this is to get rid of my i's in the denominator. So if I FOIL these two together and I'm left with I terms, then chances are I've made a mistake. So I'm going to start first. So I'm going to have negative 2 times negative 2. I'm going to add it to my outer. Negative 2 times a negative 3i. Add it to my inner. 3i times a negative 2. Add it to my last. 3i times a negative 3i. Now before I worry about doing the top, I'm going to simplify my bottom because I want to make sure that I did not actually make any mistakes here. So when I'm looking at it, what I actually have is I have negative 2 times negative 2 is 4, so this becomes a 4. I have negative 2 times negative 3 is a positive 6i. 3 times negative 2 is a negative 6i. 3 times negative 3 is a negative 9. I times I is I squared. If you look close at it, what you should see is that this middle term here, which is the piece that we care the most about, has totally canceled out. With the fact that it canceled out, this means that I have FOILed everything correctly. That being the case, I need to remember that I squared equals -1. Since I verified that I did it right, I can go ahead and FOIL across the top. So across the top, my first term is going to be 7 times the -2. Add it to my outer terms, 7 times -3i. Add it to my inner terms, -i times the -2. And add it to my last, -i times the -3i. Go ahead and reduce that numerator. So 7 times -2 gives you -14. 7 times -3 is -21i. -i times -2 is plus 2i. Negative times negative gives you plus 3i squared. And again, we need to remember that I have this I squared, which I squared is -1. So now let's finish simplifying our problem. My -14 is going to be along for the ride for a minute, and I have -21 plus 2 gives you a -19i. And then this becomes plus 3 times the -1. Simplify the bottom. This becomes a 4. My middle goes away, and I have -9 times -1. Reduce some more, and we end up with -14 minus 19i minus 3 all over 4 plus 9. So here, this is going to give us, on the bottom, 13. On the top, we're going to have -17 minus 19i. And then, of course, here we have to finish by separating it out. So this becomes -17 over 13 minus a 19 over 13i. So there you have it. Kind of a somewhat quick but full of lots of examples in working with your complex terms. So if you have any questions on any of these or any questions about the approaches that were used, please let me know. And if you feel like you need some additional examples, please put that in the comments and I'll be sure to get back to you. Otherwise, I hope you enjoy, and I'll see you next time.